domain and range. All of these on the front page are continuous. Some of these on the back page are actually discrete. We'll look at that here in a little bit. But again, these are all continuous on the front page. Domain is X, left to right, however you want to think about it. Domain is X. It's that horizontal axis. Range, then of course, is going to be Y. Range is Y. All right, for domain, you're going to scan your pencil left to right. So domain is left to right. And the way I like to say it, if you remember, is we find the lowest X value and the highest X value. With range, you're going to scan your pencil bottom to top, or top and bottom, however you want to think about it. But bottom to top is how I would like to say this, because you're going to find your lowest Y value and your highest Y value. So domain and range can typically be written using inequalities. That's what we got used to. That would be like interval notation for domain. That one could be written like, well, first of all, it would be going all the way to negative infinity. So negative infinity, comma, 2. And we would use parentheses or bracket depending on the sign. So if it was this, it would be bracket. Since it's this, it would be parentheses. Range, we would just do the same thing. We could write it, let me make one of these a bracket just to change it a little. So we would have parentheses 1, comma, then we would write our next Y, 3, bracket. Okay, so that's the same, these are the same things basically. Same things there, just written different ways. We got more used to this one. Now we're gonna work a lot more with this one. So I'll keep with my colors here, green for domain, purple for range. Range is Y, domain is X. Number 1, domain. We are going to just simply find our lowest X, which will be our most left X value. So, well, that's gonna go on forever. So it looks like it's gonna go for negative infinity that way. And then our most right X value, it goes to positive infinity. So how I really want you to start these is identify the lowest X value and then write it. So parentheses, negative infinity, comma, and then find the highest X value, or the biggest one. So it goes to positive infinity, just like that. The other way you could write that, of course, is all real, but since we are sticking to interval notation, that's interval notation down there. That's what you have to do this time. We're gonna use this one, okay? So not this one today, this one. It's the same thing. All real and this are the exact same thing. Range, you're gonna find your lowest Y value. So your smallest Y, the way we start this, remember, we're gonna start at the origin with our pencil or pen, if you're me. You're gonna go down until you don't have the graph anymore. So the graph is this thing, that V, it's an absolute value graph, but our lowest Y is right there, okay? And then you identify what number that is. So it's down 2, so that's a negative 2. All right, and then you are gonna write that. So there's a point included there, so I know it's a bracket. And then our highest Y value would come next. So, well, this is going on forever. Well, they both are. So it's gonna go to positive infinity. All right. A little bit easier to write them this way, I think. Number 2, see if you can do that one. If for domain, you should have just started by, first of all, putting your pencil at the origin and then working your way left until you're at your most left X value, which is 1, 2, 3. It's a negative 3. All right, if the graph hits that negative 3, you write a bracket. and then comma. The next thing you do is find the most right x value, or the biggest x value you have, which is positive 3. If it's included, it's a bracket. All right, range is going to be the same thing. We're going to start at the origin, except we're going up and down. So we're going to find our lowest y value, 1, 2, 3. So that's negative 3 down there. And we're going to write it. It gets a bracket. We're going to go up 3. That's our highest y value. Domain, I know, is x. All right, so I'm going to start at the origin, go to my most left x point. So is that right here? No, we have x's over here. This is an x of negative 3, this is an x of negative 5, so no. It goes on this way forever. So parentheses, negative infinity, comma. Now we're gonna find our most right x point. Is it right there? I already know. It's gonna go on forever, positive infinity. Range equals y. So what we do for range, we're going to identify the very lowest y value we have. Start at the origin for that. You're gonna go down 1, 2, 3, 4, 5, 6. That's the lowest y we can see. And these are arrows, so it's gonna go to every y value down there ever. Or in other words, parentheses, negative infinity, comma. Now we're gonna go back to the origin and we work our way up to the very highest y value we have. So 1, 2, 3, 4, 5. I know that's 5 right there and it is included, so bracket. Oops, didn't mean to take the paper with me. So negative infinity, comma, 5, bracket. All right, guys, so here's some new things you need to add on this second page. Go ahead and put in continuous, discrete, CD, 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 and then I kind of split these off. All right, so discrete, we know a good example for discrete is dice. It's gonna be like 1, 2, 3, 4, 5, 6. Okay, so discrete, you know it, no fractions. That's all you gotta know for discrete. Discrete is no fractions. Continuous must include fractions in. It includes fractions, you know, all sorts of numbers. So a table example for continuous, that would be like, I'm just making that up. So discrete, go ahead and make a example of a discrete one. Discrete isn't just 1 through 6, it's just that we can't have a fraction here. So that's still discrete. An ordered pair example, you could simply use this right here if you wanted to and write it out as an ordered pair. I'm gonna write a continuous one like this. Discrete would be, you know, etc. No fractions there. And even though if that one wasn't there, let's say for the continuous example, this would still be continuous because this could turn into that. 0.5 is the same thing as 1/2, which of course is a fraction. Mapping example, here we go. I'll do discrete first. And they don't have to be lined up with each other for a mapping. I don't know why I did that. Here we go. Here's our mapping over here. Oh, you guys can't even see my mapping. So there's my mapping. That's how I did mine. All right, I'll help you with maybe 1 or 2 of these. Actually, yeah, definitely just 2 of them. So I'll help you with number 8 here. We have to find the domain. So how are we gonna do that? Well, we're gonna start at the origin. We're gonna go left until we don't have any more graph. So any more of this U thing. That's our most left X, and we're gonna write it. So it's -1. It hits -1, so it's a bracket. All right, and it's gonna go to the right forever. It's gonna go this way as an X forever. So that's positive infinity. The range is going to be our top to bottom, or bottom to top. So we're going to find our lowest y value. Is that going to be right here? It's not, because this isn't just going to go flat all of a sudden. It's going to keep going kind of that route. That's a little exaggerated, but it's definitely going to do this way more than it's going to do that. So this same thing, it's going to go like that. And if we kept drawing that, it's going to go on forever for y's. All right, so our range is, we know we could write it as all real, but we're doing this notation, this interval notation today. And we would write negative infinity to positive infinity. How do you write your domain for this? First of all, is this discrete or continuous? That's going to be discrete, all right? So it's discrete because none of these are a fraction. And if you need to kind of write that out, you could. So I did that, it took me forever, but you could do that and then look and see, do you have any fractions? No, you do not. So domain, you're just gonna simply write out all your x's in order. So maybe that is a good way to start this, because you're gonna have to write these anyways. So yeah, class change. So we could just start writing our very most left x, which would be -4. It's gonna be this weird kind of like that, comma. Our next x, which would be -3. Our next x that we hit would be -1. The next one would be this one, which is 3. And then we have one at 5. And this one's actually 6, I realize now. So 6, because if it was 5, that wouldn't be a function. All right, so -4, -3, -1, 3, 5, and 6. Range, we're just gonna write all the y's we have. So we have one at -4, at -2, at -1, and at 3 and 4. Okay, you guys can do those. It's not too bad. I will help you. I want y'all to try that one. Of course, you're gonna have to do number 7, 10 as well. You have an example for 10 now. You're gonna have to do 12, but I'll do 13 for you. So domain, we're starting at the origin. We know we're going left to right, so this way. And we're gonna go to our most left or our lowest x value. So I know this is gonna go like this forever, so we're gonna hit every x to the left of the origin. Or in other words, parentheses, negative infinity. Then for this next thing, we have to go to the origin and go till we hit our most right x. Well, we have a circle there, but it's empty, so we know we're gonna have an x of 2 with a parentheses. All right, and now we're gonna do our range. So we go to the origin, we're gonna go down until we don't have y's anymore, or we go down to our lowest y. This goes on forever, so I know it's gonna be parentheses negative infinity, comma, and we go to our origin, go up until we don't have y's anymore. None of this has y's. Okay, so this is our highest y right here. It's empty, so we have a y of 2. No, that's our x right there. X is 2, y is 0. If you wanted to go out to the side and do that, y right here is 0. So it would be a bracket, or sorry, not a bracket, it would be parentheses, because